So for the first part, let's take a look into the objective of these presentations. Next, a little bit on introductions. So where does this mechanism happen? So this process occurs in plant cells, specifically within the chloroplast and sometimes extend to the cytoplasms. And the purpose of this pathway, so this mechanism in plants allows the mobilizations of fatty acid, glycerol, and galactose during stress, which, for example, nutrient starvations, or chloroplast remodeling, which are specific to plant metabolic needs. Is it primary or secondary metabolisms? So the gradation of Mgdg is part of primary metabolisms because it involves essential molecules such as fatty acids, sugars, and glycerols, which require for survival, energy production, and growth. The mechanistic pathway of Mgdg. The first step involves enzyme galactolipase. The substrate Mgdg undergoes hydrolysis. This reaction breaks the ester bonds, yielding monogalactosyl glycerol and free fatty acids. In the subsequent step, beta-galactosidase acts on monogalactosyl glycerol, cleaving the glycosidic bond. This reaction produces galactose and glycerol.
Next, we focus on the enzymatic breakdown of Mgdg. In this section, the enzyme galactolipase, enzyme class number 3.1.1.26 acts on Mgdg. Water H2O is added as a part of the process resulting in the hydrolysis. The enzyme cleaves the ester bonds in Mgdg, producing two key products, which is monogalactosyl glycerol, which retains in glycerol and sugar unit, and second, free fatty acids, which are released from the glycerol backbone. Moving forward, we now focus on the breakdown of monogalactosyl glycerol to produce the final products. This reaction is catalyzed by the enzyme beta-galactosidase, enzyme class number 3.2.1.23, which hydrolyzes the glycosidic bond in the molecule with the help of water, H2O. The two final products are first, galactose, second, glycerol.
Next, I will be explaining how we measure the enzyme activity using spectrophotometric enzymatic coupling assay. This assay will measure the galactolipase activity by detecting the free fatty acid release during the first step of the reaction, where galactolipase will convert Mgdg into monogalactosyl glycerol and free fatty acids. We will use couple reaction involving additional enzymes to generate a measurable product. This slide shows the overall reaction, where first, galactolipase will hydrolyze galactolipids into free fatty acids, and then these fatty acids will be activated by acyl-CoA synthetase to form acyl-CoA. Next, acyl-CoA oxidase will then oxidizes the acyl-CoA to generate hydrogen peroxide. And finally, the hydrogen peroxide will react with chromogenic substrate in the presence of peroxidase where they will produce colored product, and this product can be measured in the spectrophotometer at 540 nanometers. Finally, to analyze the result, we will plot the absorbance versus time, and at the same time, we will generate a standard curve using known fatty acid concentrations. The slope of the curve will allow us to calculate the reaction rate and determine the enzyme activity, either directly or we can also use the Beer-Lambert equation. That's all from us. Thank you.